And it is summarizing all of these to generate this answer for us. Furthermore, we can ask it to generate that salary slip, and we have written the instructions for, right? So can you get money pay slip? This is the information it will need before it can generate that salary slip for us. So my name is Jen Doe, let's say. EMB is a random number. Month Jan 25. Total salary sum again random number. Let's just type any deductions. So let's say we're gonna leave it to in order to apply any deductions actually. So just leave it this much amount of information. Okay, then it goes and asks, can you provide me deductions? So make your own calculations. In the policy document, we can actually update all this information so that it doesn't ask us. It took some random values as is applicable, tax 10%, HRA 20%, other deductions 5% on, just some random basis for now. And here it gives us the pay slip. Let's click on download, save. And this is a basic format it has chosen for now. But as I said earlier, you can give your very specific instructions about the format to be included and include that as a knowledge base in your images section. So that was one of the agent invoking. What if we want a multi-agent system? So on the UI approach, what you can do is you can create multiple of these agents like this. So you can click on place new agent, build multiple agents, and add them all together over this connected agent section. Keep on adding your agents. You can also do this programmatically. So let me just show you a Visual Studio Code in working. Okay. So if we actually have a look at this multi-agent system that we have created, you can see that it starts by adding some of the references. You can do this programmatically as well to automate it or to make it work faster. Right from the creation of the agent to actually using those agents is something that you can create in entirety programmatically. So for this, from the Azure AI agents, we are importing agent client. Okay. You can see the parameters it would need the endpoint and the credentials for authentication. Again, from the AI agents models, we are getting the connected agent tool, which will be used to connect different agents together. The message rule, so for all the values and attributions of the messages in the thread. Let's sort order. So in what order you want the messages to be displayed. Toolset and functions if you want to include any function coding. In this particular code, we're not going to use the toolset and functions, so we can just ignore that. And for the identification authorization, we are having this default Azure credentials. So first of all, get started by loading the variables of project endpoint and model deployment from this .env file. So we go to .env over here and We need the endpoint of the project, which is available in the overview section. I'm going to copy this endpoint and you have to specify which model deployment you want to use here. So let's save this. Coming back to the Python code, this is where we connect to the agent, right? So agents client, using that we build this agents underscore client. Right? With this agents client, we have three agents as worker agents and one manager agent. What are the three different agents? We have number one, a priority agent. You can see the instructions for these priority agents as well. It is going to assess how urgent a ticket is. So whenever any ticket is raised to the manager, this agent will assess it and tell us how urgent the ticket is. Is it high? What is the urgency level? High, medium, or low? And it will give the output in terms of this high, low, medium. Create agent block is run. And we create another agent, which is team agent. The job of this team agent is to decide which team should work on this ticket, whether it's going to be the front end team, the back end team, the infrastructure team, or the marketing team, right? And again, create that agent. Then comes efforts agent. Okay, estimating work for each of the tickets that is raised, on what scale this needs to be completed, small scale, medium scale, or large scale. So we're giving the instruction to each of the agents over here. Now over here, we are connecting all the three agents together so that they can work in sequential or parallel order. And this is our manager agent, our orchestrator, which is a triage agent. The instruction is a combination of all the steps together. Triage the given ticket. Use the connect tools to determine the ticket's priority, which team it should be assigned to, and how much of effort. So you can see priority will be decided by priority agent. Which team will be decided by the team agent we have created above, and the efforts will be decided by this efforts agent. Right? We're using them kind of like a tool. So that's our agent in working. As soon as the problem starts, it's going to ask us what's the support problem you need to resolve. Okay. Then processing agent thread, please wait. If there's a failed error, it will give us the error details. If not, it will successfully run. And then every detail will be sent our way from the model. Let us open this and integrate a terminal. What's the support problem? So let's say that. The RMS application is not authorizing users at the login screen. So that's the problem. It's processing. All the agents will work and give us the final output. The triage agent will get back the response. This was the problem we raised. Triage summary says priority is high. The user is feature facing issue blocked out the login functionality itself. Assigned team, it's going to be the backend team who will resolve this. Effort estimated that this will require medium level of or scale of efforts. So accordingly, we can raise the request for support ticket to be raised with this. This is how we build up a multi-agent system. Now, programmatically, you can just copy this code as it is. And instead of these agents, you can change their names, you can change their instructions over here. What is it exactly that you want to do? What you want each of these agents to do? Instead of three, you can have four, five, multiple different agents. But yes, more complex network there is, the more time it is going to take for the entire processing. So this is how you can bring multiple agents into working, either from your code or also you can, we have seen how we can make this playground also work for us. Okay. We can also try submitting an expense ticket. So let's try that. I'll show you one more UI-based approach demonstration. Give me just a minute. I have some instructions that I'll copy and paste. First of all, I click on New Agent Creation, then Expense Agent. So you can see, just have a look at what the instructions are. It's for corporate expenses. It is going to answer questions from the expenses policy data. And when a user submits an expense claim, it will ask for their email, the description, and the amount, and the user can download it. Let's update the knowledge for this. This is the expense policy. Upload and save. Same way, we'll get the code interpreter also in the actions. Give 1 second, you plug in the charger. Okay, so we have the knowledge, we have the code interpreter, we have all the instructions. Again, so we'll ask this. How much can I pay over meals? $50 per day for meals. And you can see again this is coming from the policy over here. The version, the limitations and some exclusive instructions also, what is allowed and what is not. Now we go forward and we'll ask it to put in submit. Expense pay Let's get the email description and amount. Breakfast costs me $20. Let me just close this VSA. Okay, let's download. Is still working? No. Let's download this now. And here we can see exact details that we have given it has put that on a text file. In the same process, we can attach it in the knowledge base. We can attach some of our databases, or let's say you can update a CSV file, and you can ask this agent to actually create a pie chart or a column chart for you. So that's also a possibility. And again, thread them together to optimize. So you can go to the template section over here, and there are lots of templates for building your agents, getting started with code work also. You can clone these repos and make these codes work at your end. Like this one's gonna need the agent service, the OpenAI, container apps, and such. Again, you can see this one needs semantic kernel, and so on and so forth. So whatever work that you want to achieve and the databases that works for you, you can open the Git repos, clone it, and get started with your own agentic flow system that you can build. Let's go back to the slides now to cover up some more theoretical section. So we've seen the Azure foundry, we've seen the core features and architectural components. So the entire life cycle of an agent revolves around operating it, deploying it, maintaining it, communication protocols, which you can mention in the instructions. You can monitor these agents continuously because there's observability. Each agent, the errors, the performance. So if I just show you, go to the agent section, open any of these agents, let's say the triage agent that we have programmatically just created right now, open and play account. You can start interacting with this triage agent. You can see that the instructions you have given are also available here. Maybe you go back to the agents again. Effort agent, again you can see this instruction. Let's say for expense claim, what was it that you discussed? You can know from the thread section. So go to my threads. You can have a look at this particular thread, no message found. This one, the one that we just ran, you can revisit this or even programmatically when you performed something. Let's try background. You can see this was the agent effort agent. It was given this problem statement. It classified this effort level as medium. This was the justification, and that was the output given by this particular agent over here. So that's what we mean by this observability and monitoring. And there's modular architecture available for this to handle even complex workflows. Integration, so you can integrate this with Kubernetes, serverless function support, monitoring and observability is possible, and the secure identity management is also available. And we are orchestrating this multi-agent. There are messaging protocols. So your message should be very, very clear. Your instructions should be enabled for the agents. There are some negotiation mechanisms when different agents are collaborating, there's possibility that two agents may say opposite thing. So there are mechanisms to resolve that, and the synchronization methods are also available. You can instantiate the agent, you can monitor the health, the workload-based scaling, as well as you can terminate any agent as well. It's just like hiring a team for a project, and if the performance score falls down, you can terminate that agent by just deleting it. So it's like without actually paying or hiring someone for work, you can still get the job done. We're not talking about replacing humans, of course, but yes, a lot of redundant manual tasks can be handled by these agents, and they will act like assistants to the human workforce that we have. Leveraging Azure tools, so workflow managers, you can use event-based triggers. Automatically, an agent will start working based on occurrence of an event, and you can also monitor the performance on the dashboards. Security monitoring and some of the best practices. So authentication you can manage as a system-based identity or as a managed identity. There is authorization required, as you can see even on my code. I had to provide the endpoint and the key, and I have already run the easy login from my system, and that's the reason the authorization worked for me. Is all encrypted, the data is secure, and there are some compliance standards also to be set. In the monitoring and logging, you can have all the anomalies detected. If an agent didn't roll it right, you can flag that as an anomaly. You can track the overall performance and you can diagnose and troubleshoot as well. So have a modular design that is very flexible and maintainable. You can do incremental development. So when you're creating this multi-agent system, you can build it up agent by agent and then connect it all together progressively. Overcomplications is something that we should definitely avoid, and we can have scalable and secured solutions that we can build. Okay? So that is all from my end in this session. If that was an interesting topic, there are a lot more learning resources and practices that we can do. You can join us for a 1 day session, which is AI 3026. Or if you're interested in the generative AI, how to have different GPT models or different generative AI models into working, how do we use them, plus this agentic AI plus a lot of classic systems as well. All these together you can cover in a 5 days course, which is AI 102. Along with this, you can also take your exam, the certification exam for Microsoft. You can become a Microsoft qualified data specialist, a data scientist, rather, right, or data engineer, and you can work for organization under this capacity once you qualify this. So this will make you a specialist on Azure AI services and the Azure Foundry. So that will be all from my end. Don't forget to complete the feedback form. And if you do have any questions, let me know in the chat. And also sharing again the redemption code in the chat. Have a look at this. You can redeem this code on your personal accounts and earn some badges and trophies on your profile. So you can use these trophies on your resumes, or you can share them on LinkedIn of having completed these modules for this particular training. This will be all from my end. If you do have any questions, I'm right over here in the chat. Let me know. Don't forget to redeem the link. And also, I'm dropping in the code if you want to connect us with us for the training. You can write back at the Coding Webinars email address. I hope you enjoyed the session. Let me know if you have any questions, and Yes, that's all from my end. Thank you all for joining in. Hoping to see you some other time in some other session. On that note, take care.